But we're here today to share about Oregon State University Cascades Campus, their academic building too. And really it's about flexibility, adaptability, net zero, mass timber to yield a prototype. So a little bit about the project, just to get the parameters out there. It's a 50,000 gross square foot mass timber structure. The construction type is 3B. It's glulam columns and beams with CLT floor and roof. The lateral system on the project is concrete. We're looking at a 12-week or better mass timber schedule. Our typical bay grid is 10 by 32. We have a lot of unique services within the building because it's kind of key to an expansion that Lisa's going to cover here in a minute. We have labs, cadaver labs, maker spaces, offices, classrooms. We're looking at a completion in 2021. Our client is Oregon State University. We are in a CMGC role and we are self-performing the mass timber. We have the architect SRG partnership and structural engineer Katina.
And we maybe should have Jared just briefly introduce himself since he's on the call.
That'd be great.
Jared Silva, Oregon State University Cascades Campus. I'm the owner's rep for the project.
Thanks, Jared.
And leads the team. So one of the things, every project kind of has its North Star, and so wanted to kind of share that because it really starts to reflect the approach to the project. The principles are do no harm, do good, and lean into the future. And so it really responds also to the place that the academic building is located in. But those of you who know me also know that it's about people, not product, and that people are connected to wood. And I think that's part of what makes our group of individuals within special in how we engage with it. And I like to share that I'm connected to wood, and one of the things I identify with is I think about my grandfather and his brother as young men in the 50s on a logging operation in Southern Oregon, and really think about the 4 generations prior that are in the timber industry. And it really resonates for me on how I feel connected to wood.
And William asked me, well, what's my connection to wood? And I had to think a moment. And then I thought back to my family home, which was built when I was 3 years old. My dad was the primary driver. And probably around when I was 8, I realized that my home was different than other people's homes, especially on the outside with the siding running vertical. But mostly it was the color of the siding that was different and how it actually smelled great after it rained. And it had texture and it changed based on direction. And what happened next was that I went with my family to visit the redwoods from Montana. And my dad said, that's where our siding comes from, those trees. And it opened up possibilities and ultimately led me becoming an architect in some ways. So this is the Cascade Campus as it exists. Well, actually, this was probably a year ago now because we've been filling in the mine as we speak. In the foreground is the 10-acre site, which consists of 4 projects right now. The 56-acre site was a former pumice mine, and Jared has spent the last 2 years of his life doing a reclamation of that mine. I'm sure he would love to chat with you about that at some point. There's also 2 distinct different landfills and a third that we're also going to be remediating in the future. If you go to the next slide. This is the overall master plan for the project, which was developed by Paige in conjunction with Sarah Architects. You see in brown the 10-acre site, which consists of 4 buildings, 2 residence halls, a dining hall with classrooms, a classroom building, and then a science exhibit center. Our building is the orange building directly adjacent to the 10-acre site. And you can kind of see by the forms, it's right on the edge of the mine. And in addition to the main building, we're also doing a central energy systems utility building. And William will talk a little bit more about that.
So the project that we generally attribute to our efforts currently is building a in addition to the academic building, is a campus energy transfer station. This is part of our net zero strategy, as it will work between the injection and extraction wells that are part of the geo-exchange. We are doing restoration landscaping along new roadways and paths, providing connections from a surface parking lot down to the academic building. We'll also be incorporating an oval green space that'll be the center of future development and the center of activities on the campus. So,
when the OSU sent out a brief, let's see, a year ago in February, it was an amazing challenge for architects, engineers, and contractors alike. Design a 50,000 gross square foot multiple program building that meets 3 distinct goals. It needs to be flexible and adaptable to create a prototype for the future for those other buildings that you saw in the master plan slide I showed earlier. It needed to prove that net zero energy was possible on a single building because the overall campus was designed to be net zero energy, and this was a proof of concept. And oh yeah, just include a meaningful use of mass timber. You know, and by the way, do that in a mine that's with a landfill that was still evolving as we designed it. As you can imagine, this challenge was super exhilarating, and it really made us think about what it would be like to be in that place. Go to the next one. So we started with the prototype, and the prototype really consisted of these series of different modules that were around the program itself. We wanted to make sure that we would create a flexible, adaptable space that take good advantage of the modules of the learning spaces, the office, the creative spaces, as well as the social hub. Go to the next. When we started to lay out the program based on our past experience, we knew that a 10 by 30 foot bay really works very well with labs and classrooms and maker spaces. It also can work with office suites. And so we started to normalize the program around these 30 by 30 blocks, which then allowed us to create this flexible grid that would allow us to organize the spaces either by program, having one academic program together, by energy use, where we grouped activities with high energy next to group activities that had low energy, so there could be transfer, or by activity, which rooms needed more natural light and which didn't. Ultimately, what we did was we had all of those drivers help to inform where the places were in the program. But this is important because it started us on a module for the mass timber conversation that we'll have later. Go to the next. When you're designing a net zero energy building, its form and massing and orientation is super, super important. And so we looked at how we could create a simple form, fit it into the landscape, and basically allow it to use as much passive systems as we could, taking advantage of the earth and radiant piping in the slab, making sure that we had a great shading system on our elevation so that we wouldn't get too much thermal gain, having then the rooftop area for PV and incorporating this geo-exchange system that William mentioned. Next slide. So when you're looking at a net zero building, you have to think about, it's a chicken and egg kind of problem, really. Do you start with the overall uses and what the energy is that they need to accomplish, or do you start with the roof area? In this case, we did it both. We did it iteratively. Looking at a PV watts type of tool, we could figure out that our roof area would be able to support a building with an energy utilization index of between 26.7 and 28.6. And for a lab building that had a cadaver lab in it, that's actually a fairly low EUI. Go to the next one. And then when we went to the other side, and again, I don't know if this is the chicken or the egg, but the other side is what were the uses and where did their energy use actually mean in terms of what they would need. For the spaces, the combination of spaces that we have in our building, that would be a typical building, a code building would achieve an EUI of 80. So through the passive strategies that we incorporated, such as natural daylighting and passive cooling and the thermal coupling of the land, through a great mechanical system that incorporated those geo-exchange wells, we were able to cut the energy use by over half. Then we worked with Jared and his team on some operational strategies. Could we shut parts of the building down when it's not occupied? Could we set different air change rates? And we were able to achieve another significant lowering of the EUI, but we still weren't quite there. We needed to get to a target of between that 26.7 and 28.6. Next. And so what we did as a team is we came up and brainstormed, had a session in our office where we looked at a whole series of energy conservation measures that would lower the overall EUI, but they were things that weren't currently in the project budget. So William and his team costed those particular strategies at the same time as my engineer was doing the energy modeling and figuring out what the EUI savings would be associated with each strategy. And then we came up with this EUI per first cost acronym or number that quickly allowed us to figure out which systems needed to be incorporated into the building in order to achieve the overall project goal. Next. And now, why we're all here, the meat of the discussion. How did we go about getting a meaningful use of mass timber?
So the question we often ask is why the move to mass timber? And so it's taken on different meanings over the last 4 or 5 years as we continue to advance projects through. But we really kind of start with the discussion with a Lotus that I worked to create with others to really highlight some of the opportunities for cost and value considerations with mass timber. Obviously, labor, prefabrication opportunities, sustainabilities, these are kind of core. Aesthetic is an easy one to answer, but there are also schedule and structural efficiencies, but all outside influences that we start to look at. Much of it, it's interesting because a lot of the mass timber buildings actually consider energy use, just as we've discussed, and really drive that. But obviously the interior aesthetics really speak for themselves. The central stair and the image of what the space will become really starts to speak to the beauty of the building. But some of the other opportunities for this specific project really include the benefits of supporting a regional economy. Speed of construction. We're looking at an overall duration on this academic building of 13 months, which is a really phenomenal speed of construction. Carbon sequestration, improved daylighting, renewable resources, the biophilic response, all things that the design and construction team and the owner thought about as they considered the incorporation of mass timber into the structure. But where do we start? Lisa mentioned earlier, talking about a 10 by 30 grid and how that might materialize. But we also had the responsibility to demonstrate the financial benefits associated with mass timber. So as we explored it, we looked at different framing solutions and how it might compare with structural steel as a baseline that otherwise would have been considered for the project. We looked at the layout of the building, the aspect ratios of the building, the ability to distribute mechanical, as you notice in the middle, in the middle bay of the lower tabletop images. There's a lot of opportunity for distribution of mechanical down the corridor and then distributed out into the classroom and lab spaces. But to get there, we really talk about the approach to the team. We live in an industry that is siloed and redundant and inefficient, but that can lead to premiums. Getting past neutrality to cost savings really takes a highly collaborative team, and we benefited from OSU really kind of engaging with SRG and Swinerton in how we approach the project to do more than what our contracts describe, to do more to yield outcomes on the project. And so through that leadership, we really were able to become a highly collaborative team, and we think that this is part of the success of what the project has been able to achieve thus far. But the sustainability scorecard is very much on our minds. We don't tend to lead with this, but it's really looking at the sequestered carbon and really the time for North American forests to regrow the wood. That 3-minute period, much less than the time that we're going to talk about this project today. But it all starts with building type strategies. And so one of the things that we did even early very early in the project and really started with a pre-app with the City of Bend was really talking about our approach to the building type. As we all have come to learn, type 3B really is a sweet spot for the structures that are of this nature until we start to push high with the new type 4s. And so if we look at a 4-story structure, 3B is the best, can be the best outcome because of the non-rated aspects of the structure. And we recognize the premiums associated with the fire ratings to gain the char layers within the solution. But we had additional considerations that Lisa's going to chat about.
Yeah, so in the diagram, if you've noticed, the exterior enclosure was a 2-hour rated. So that was really important. And if you remember, I started by talking about a 30-foot module, and William said it was a 32-foot module. Well, the secret of the difference between those is to put the columns inboard of the actual structure, which you see on the diagrams on the right, so that they're not inside the exterior enclosure and they can be free and clear and therefore expose the wood, and it can be part of the aesthetic finish. In addition, though, there was a couple of places where we couldn't quite do that. The exterior colonnade that you see on level 1, as well as on level 0, if you go to the next slide, there you can see the extension of that colonnade. And so for those exterior columns, they had to be rated because of that requirement of the 3B construction. So in that case, we wrapped the gypboard, the glulam column with gypboard, and then put a metal cladding, basically it's a protection layer on the exterior column. Another important thing with the construction type that William was mentioning is really understanding how that integrates with the occupancy. In this diagram, the blue is the B occupancy, which is the primary occupancy of the building. It's for a higher education. Green is service. Again, it's pretty typical for a higher education building. And the pinkish color is an assembly occupancy. In this case, OSU wanted to have a flex space that would be able to hold up to 200 people in seats on that central stair for a tech talk type of arrangement, or they wanted to have conferences with the 2 classrooms that you see, so well above the occupancy that would be allowed in B. Now, in order to achieve that in 3B, we would have to have done either of 3 things. Either have it essentially be a smaller building, which OSU wasn't interested in, have the occupancy, the A occupancy separated from the B occupancy, which wouldn't work with the program and how it would flow, or essentially rate the structure, which would have added cost or make it a different kind of structure. So what we did instead, if you go to the next slide, is we said, we want to do option D. What if we went for an alternate means and methods where instead of doing the separation required, we asked for an exception to the code by proving that we equally meet the code's intent. And how we equally met the code's intent is doing a timed egress analysis that first of all showed how quickly our occupants could get out of the A3, and then protecting additionally, not just the A3 occupancy with additional fire sprinklers, but also the areas that you see in the red hatch that surround the A3 occupancy. And with those 2 strategies, we were able to convince the jurisdiction that this equally met the code as a fire separation would have.
That was a tremendous win for the project. I mean, the cost benefit, as mentioned, is on the order of $10 a square foot on the gross structure. So it's a big benefit and a big win in helping us to drive toward budget. So the next portion of the project or the presentation, we're going to chat a little bit about suppliers and kind of approach to the mass timber frame. And so one of the things that we've become increasingly aware of, because it's increasingly part of the dialogue, is talking about sustainable forestry. And this is something that is particularly meaningful for the design and construction team as we look at mass timber solutions. So the tenets of sustainable forestry: prompt reforestation, protecting water resources, protecting wildlife habitat, and limiting clear-cut size, factor in. We kind of care where the wood comes from. But the other thing that you're going to hear a little bit about today, but probably the subject of a future presentation, is really talking about restoration forestry. And I'm tipping my hand for those that know the suppliers, but the idea of really thinning approach, maintaining ecosystem diversity, resiliency, and approach to forest management is a key part. When we look at our supply locations, we're now looking at a lot of different options. As the market has continued to grow over the last 4 or 5 years, we're seeing a robust diversity of our sources in North America, but also seeing European manufacturers start to come into play in a significant way in our projects. We also have a fabrication facility in Portland, and really use that to kind of support the diversity of sourcing in our projects. But as we look at the individual suppliers, we start to wrangle with a lot of different panel sizes. And so as we work through that, our optimization of frame really starts to impact how panels are more efficient. So when we look at individual manufacturers and say this is an example of a 15-foot span versus a 13.4 span, when you compare the vendors A, B, and C, you can see how the percentage of waste changes depending on your bay spacing and the panel sizes. And so there's a strong correlation between manufacturers, panel sizes, and cost. And so where we ended up with on OSU Cascades and balancing all of those aspects is really looking at integrating through Swinerton Mass Timber, Vaughan Timbers out of Colville, Washington, Ferrer's Lumber for the central stair piece, and then Zippo laminators in Eugene for the glulam posts and beams. So if you think about that and think about the rural aspects and some of the earlier objectives we mentioned, Vaughan Timbers is the furthest way at 445 miles, but Ferrer's Lumber is only 110 miles away, and Zippo is 135 miles away. And so you start to look at the correlation between sourcing of timber, the manufacturers through the fabrication steps, are really starting to strike at efficiency within the structure. And so as we look at the bay spacing, the other thing that we look at is opportunities with optimizing the fiber. And so as you can see in the comparison, and really just going to the bottom line, the difference between a 5-ply panel with a 13.4 on-center spacing versus a 3-ply panel with 10-foot really yielded a significant reduction in structural material. And we were able to do this, and part of this equation is also decisions on how you approach the diaphragm. OSU saw benefit in having structural concrete as the diaphragm on the floors and really tying that together in the solution. The other thing to think about is the panel size versus quantity. And so some like an 8x40 comparison versus a 4x60 comparison on the floors, part of how we look at that is really strategizing on how we get the timber in place and how many pieces you're placing. And so when you start looking at the quantity of panels, you can see how that can jump significantly. And so erection and installation is a key part of it. And so part of what we try to drill down on is kind of equalizing that approach. So the real metric starts to become picks for installation given the speed with which we can install mass timber pieces. And so you can see on a typical floor plan with a narrower panel, we can do bundled picks versus single picks off the truck, and then looking at certain panels that we might need some strong backs to get them up in the air. And just to bring it more visually home is thinking about our crane and access to the site is really driving the weight and the amount that we can pick in a bundle. So as we get further away from the crane, the fewer panels that we can pick into a solution. And so you can see though how it comes into play with a very modest crew, and they can quickly install the panels.
So pretty clean rendering, huh? And you're saying, wow, well, that's not really going to be the way it looks. Well, that was one of the other key goals for our team, was that we really wanted to celebrate the mass timber, particularly in the teaching spaces. If you go to the next slide. William's kind of already mentioned this, but part of that solution was to look at the corridor spacing, and you can see that the corridor beam is much shallower than the beams that's needed, because we basically put the columns on the corridor side of the room, allowing then to have more free area for ducts to run down the middle of the building, keeping them outside of the classrooms themselves. We also, because of the spacing with the 10-foot, we were able to eliminate any beam running perpendicular to this drawing that would be between the columns, allowing then mechanical to go straight from the corridor into the room without needing to penetrate any beams. Next.
So really, when we started looking at the mechanical systems, you kind of go back to the uses and kind of what our opportunities are, keeping in mind that we're iteratively trying to work towards that 26 to 28 EUI, or energy use intensity, to yield the outcome. So, you know, we looked for opportunities for passive systems like in the flex lobby down on the lower floor, but also looking at classrooms and layout, with labs and the cadaver lab really being kind of the energy hogs relative to the mechanical system. So that started to inform our opportunities for different mechanical systems. And we employed a choosing by advantage approach in selecting the mechanical system. As those of you have heard me talk about in other presentations, the interplay between mechanical and the mass timber frame is key. And so you really need to kind of set those strategies early in the design and really take decisions. And so using this choosing by advantages, we were able to kind of score criteria, or rather have OSU score their criteria and correlate 3 systems that we ultimately considered. And so as you see the first cost charted against the CBA score, there's a pretty strong step from VRF to sensible fan power boxes, but a very slight step for a significant costing increase to go to a full chill beam and radiant system. And so ultimately, that drove us toward the sensible fan powered boxes.
But the decision doesn't just end with the first cost. There are other implications in terms of how you go about achieving that system and how you integrate with your sustainability goals, and particularly the percent glazing. So in this particular example, what we were modeling is understanding what percentage of glazing would allow us to use each of the different systems, with going to a system, the 31% glazing, allowing us to use virtually all of the systems. The 35% glazing didn't allow us, wasn't possible within the radiant panel solution, which ultimately we decided not to use. But if we went to 39%, we also would have eliminated the hydronic fan power boxes as an option. So ultimately our team selected the 35% glazing and worked hard to maintain that glazing percentage throughout the building and not exceed it. Because ultimately, if we exceeded it, we couldn't go back and have that hydronic solution. It just wouldn't have been possible due to the loads. So if you go to the next slide. So remember that pretty image I showed you a while ago? You're saying, well, now how do you get all of the different systems and run a fan-powered system in this particular mass timber and not have it be exposed? So here you see in this diagram, the ducts in the corridor underneath that shallow beam, and then coming out towards the exterior of the building is the hydronic piping. We're tucking that hydronic piping in the corner next to one of our beams on the side opposite where the door entry is, so it's very invisible. That's the piece that you will see in the project. Then it goes into the exterior wall, and we've created a cavity within the exterior wall that the piping runs horizontally, and then it feeds these fan power boxes, which you see images of on this slide. Go to the next slide. And it's not just the mechanical systems that we also needed to really think hard about how we were going to achieve the look that we're trying to. This is the machine shop. And as you notice in the machine shop needs to have a lot of power available. And so we we're talking about with the faculty about having cord reels that would have power that would be able to pull down. But how do you achieve that without having additional conduit in the space? Go to the next slide. So one of the things that our team really took a deep dive in is working with our trade partners on mechanical and electrical systems and using our tools of BIM to really coordinate and understand where all of those boxes would go and how they would be connected. We're essentially using the concrete slab, the topping slab, as the location for the conduit, which you see in yellow in the middle image, going to the electrical box, and then the green is actually the penetration going through the CLT. All that had to be modeled so that we could have it be cut in the factory out of the CLT. And now you see for our projector, these 3 boxes that are all in a row were needed in order to power that projector and provide the AV connections in order to achieve that simple look that we were trying for. So a lot of work in the BIM fabrication to achieve that. Next.
So one of the things that we often talk about also are connections. And so I think as we continue to deliver more and more mass timber structures, we are in better positions to have the conversations earlier with the structural engineers and really drive at simpler solutions that are more universally applied within the structure. And so we continue to seek to resolve these issues of what the connections are earlier and earlier in the design process, earlier than we typically would in a common structure. But it's great to have that, that library of details and really be able to have those connections.
Another story that we wanted to share with you was this idea of this central stair. So the function of the central stair was both to serve as seating for this larger tech talk, but we also saw it as a gathering spot for students because the flex lobby, essentially by day, it's a place for students to hang out and study. As we started to explore the different systems and whether to use mass plywood or CLT, we ultimately landed on CLT for a lot of reasons for the overall structure, but we wanted to include a meaningful use of mass plywood as well. And so we landed on it being the structural material for the stair. If you go to the next one, William. The reason why we were looking at it was, first of all, the structural properties, but with mass plywood, what's interesting about it is the ends of the mass plywood. So where you see the end grain, that's the part that's visually interesting as opposed to CLT, where the visual interest is actually on the face of the panel. So in this case, what we're doing is we're exposing the end grain to the corridor as well as to the area above. And you can kind of see the detail where the stringer is a mass plywood, and you see that an end grain, as well as each different tread, you see the end grain, which celebrates then the mass plywood. Top that mass plywood off with a linoleum for a wear layer so that when you're actually walking down the stair part of it, you're not incurring a lot of wear in the overall stair tread. And next slide. And down the road, this will be a lot more visually interesting, but this starts to get you an idea of where we are. And it's always an exciting part of a project for an architect when you start to see the vision taking form. But there you see where that central stair is going to be in that space, and that you're starting to feel the flex lobby and how that's going to be like when you're sitting there.
So we wanted to end our presentation with a few photos of the progress on the site. What's interesting is this was a little over 3 weeks ago on Monday, and really the slab on grade is just going in over the radiant systems at the lowest level. And then this was actually on Monday, just this last Monday. So we love the speed of it. You can see how the lateral system, we've employed the strategy of bringing that ahead so that the mass timber can really take advantage of the crane time and move at the speed it wants to. And so a couple of artistic shots of the braces, the columns and beams. a little bit of the bend blue sky that makes it so beautiful in the summertime and the play against the wood. But really want to say thank you for letting us share about this really exciting project and the progress it's bringing. I think it really will provide opportunity for us to continue to build in positive directions with future buildings.
Thanks, guys. Thanks. It was a great presentation. We will open up the floor. Does anybody have any questions? Please feel free to just go ahead and ask.
I've got a question for Lisa and William. Vibration sensitivity is often a concern in a lab building. Can you talk about the conversations around vibration and perhaps it's the program? Is there not much sensitive equipment that is of concern in this particular building?
Yeah, this is primarily more of a makerspace type of a project, as opposed to, you know, where it has significant research around, you know, where you'd have centrifuges or things that you would really worry about vibration control. But that being said, we did have one particular space, the machine shop, that we had some specific concerns. And I don't think we actually have the slide today, but what we ended up doing was doing a vibration analysis with the particular machines. And we did end up adding some additional beams specifically under those pieces of equipment that would allow for the weight and to address the vibration, because the 5-ply, where it was obviously would have been helpful in terms of addressing that particular room, but we didn't want to have the 5-ply everywhere because of the cost reasons William had mentioned everywhere. So adding the extra beams for that room was a good solution.
Yeah, I concur with Lisa's statements. I think that the challenges for the uses we had in the building were more related to energy. Thinking about a cadaver lab where you're continuously moving air, and you know, the machine shop ending up on an elevated floor. We did keep kind of the kinesiology labs and force labs on the lower level, again, to mitigate some of those pieces, but it was definitely a consideration in the timber design.
I have another question for you. The solar array size. I understand that lab buildings are generally highly energy consumptive, and I'm struck by how small of an array that is, even though it's the whole roof for such a building. Can you talk a little bit about the that challenge?
Sure. So, and again, it probably relates more to the specifics of what are in the building as opposed to a typical lab building. So our highest energy use by far was the cadaver lab, followed by probably the engineering research space and a flex teaching space. Other spaces included art spaces, as well as we have overall just general classrooms. Those spaces blended together equaled that EUI of 80. If this had been a true lab building, we would have been starting with an EUI of more like 200 to 300. So it's the specific makeup of the spaces that allowed us to start at 80 and get down then to the mid-20s that allowed us to achieve the net positive energy.
Great building. Thanks for the presentation.
Thanks for the question, Scott.
Can you tell us what the, oh, sorry, what the facade is? I'm trying to see from the photo.
Yeah, so the east and the west sides of the building are a wood material. It's a cedar siding essentially. And then the north and the south is a combination of a corrugated metal panel and a flat panel that's underneath the windows. And the purpose of the corrugated metal panel was actually to give some depth to the facade that would allow for some shading of the windows. Again, it goes back to that energy strategy and making sure that we can accommodate the the sensible fan powered boxes that we chose to use a deeper than normal profile with the metal siding.
And we employed a Cascadia window system, so all the
Yes.
benefits of really the things that contribute to a good energy model in envelope. And then there's a large glass reveal that's here as well as on the colonnade, but those are all undercover. And on the north facade, there's a corresponding kind of solid piece on the south facade that is aligned with the core of the building. And so kind of the bathrooms and service entry, et cetera. And so it was laid out in consideration of some of those energy pieces. And even though there are reveals under the deep overhangs at the corridors, so they kind of daylight to vistas, there are also minimal pieces in the east and west to again contribute to that energy model and give us the ability to reach our energy goals with the sensible fan power boxes.
Thank you.
Greg, I saw you had a question.
Yeah, I was interested in understanding more about your selection of the acoustic assembly of the floor is what I'm most interested in. You have hard surfaces on both sides, and you have a lot of kind of loud program and all that, and how you went about that.
Yes, so we didn't actually mention the entire team, but we do have Acoustics by Design on our team as our acoustician for the project. And what we were looking at with them is, first of all, from an impact noise perspective, most of the classrooms are either a carpet material when it's a general purpose classroom. For like the cadaver lab, we have a resin material so that it has additional padding. And then for like the machine shop, which was probably the biggest concern, we looked at inserting potentially an acoustic mat between the CLT and the concrete surface. Ultimately, we decided to put the machines themselves on vibration isolators to separate them from an acoustics perspective from the space down below. And then in addition, we looked at absorption within the rooms with acoustic panel material, both in the ceiling area as panels that you saw in some of the renderings, and then on the walls in the classrooms.
So what is the typical floor assembly?
So the typical floor assembly is a 4-inch concrete slab on top of the CLT with a floor finish material that might be carpet with an Acoustimat surface that would be below it as a pad, or another, depending on the actual program space, it might be more.
Nothing at the interface between the CLT and the concrete?
We ultimately decided against that after studying that for the machine shop. Had a lot to do with the constructability and being able to get it constructed.
There are additional challenges associated with that are becoming more clear. So it's something to think about, that acoustic assembly as we work through it. And I think it's a definite benefit, side benefit, and there's some really good information on Tallwood Design Institute's website for some ongoing acoustic studies that has been a tremendous resource to a lot of design teams.
Okay, thanks.
Thanks, William.
Thanks,
Yeah,
Greg.
and Judah Shine, our director of design, is in the audience, and she can also maybe speak to acoustic testing facility that her and some of her colleagues are working on in the Willamette Valley, specific to mass timber. So maybe we can open up the floor to that later. But we do have a question from Joe Mayo. William, he was asking how the bundling of panels worked during erection.
How the what? I'm sorry.
How the bundling of panels worked during erection work.
So in that image, basically, we're lifting more than one panel at a time.
Maybe go back to that diagram, William. You can.
Sure. I pulled everybody's smiling faces over the top of my screen, so I need to apologize. So what you're seeing is the different approach, but essentially when you have a bundle is basically bringing in multiple panels at the same time. And so what you can see here is they'll lift the bundles into place and then pick them side by side rather than pulling individual panels off of the truck. They're basically bringing a bundle onto the deck. I don't know if that answers your question.
Well, we'll have to hope so.
It's Judith. Actually, William, I had essentially the same question. And so do you drop them one by one from the crane onto the glulam beams, or are they dropped onto the deck and then moved individually from there?
They're brought onto the deck and then kind of shook out from there.
Okay. Joe, did that answer your question?
So Judith, it was fascinating to watch. We were on site last week, and I know I just stood there for a while, and probably about 15 minutes, and just watching them. And they basically laid it down on top of the glulam beams, and then just slid them off. And then it basically, you can see it's depending on the length of the panel. It was 2 or 3 people that were doing this work, and we were timing it, and it's about 15 minutes a panel at this point. And I know William was working to reduce that even more. So.
I can imagine. I was wondering about that, about the trade-off in time to put in the smaller panels, because there's more of them, versus just doing bigger panels, versus the efficiency of the 4-foot fitting, exactly into the 32-foot. And I'm sure, William, you have spreadsheets looking at all those labor and cost saving factors, which I'd love to explore in detail.
Yeah, and we've got talented detailers. I see Ben's on the call, but we similarly put a project together, and it's amazing to have people who have touched it come out and really just see it slide into place. Wouldn't you agree, Ben?
Yeah, and I didn't have the opportunity to work on this project, but one challenge that I did hear about with the longer length panels was navigating through the town. That the 60-foot long panels off the end of the truck actually posed some problems getting through some roundabouts and whatnot. So it's funny what you run into, until you do it. But yeah, it's a cool project.
Yeah. Ben actually worked on our Shenectady Community College project that went up very quickly with mass plywood panels as the deck material, and within a week, the 15,000 square foot agricultural complex was erected. So, and a lot of that has to do with how we think about everything from the detailing of the panels to pick plans and approach to the installation of the projects. So, thanks, Ben.
Yep.
Was a sealer applied to the timber in the factory or afterwards?
So, same approach that we've typically done with you, Scott. It's talking about the dealing with end grains, and then on the glulam, it's the typical 2-coat process. So CLT, again, people are not sealing the CLT faces because of what you'd have to do to flip the panel in order to apply evenly to both sides.
And on the 60-foot panels, were they bundled, or did that have to be a single lift?
So if you,
Thank you.
so the short answer is yes, but it's really looking at the distance. If you think about it, the crane's sitting out here, and so the ability to, on these longer panels, they're more single picks when you're getting out towards the tip, and then looking at bundling strategies as you're pulling closer to where your crane is.
Thanks.
So, I mean, we're seeing similar deck areas get achieved with the narrower panels through strategies we're employing on the installation for some of the wider panels like we employed at First Tech with you, Scott.
So it looks like there's a question about if the panels were laminated, nailed, adhesive, or other. I'm not sure if you mean when they're picked or in the factory on that question from Joanna.
In the factory, the manufacturing.
Oh, yes. So it's a typical CLT. So they're laminated.
I thought I'd just add that Vaughan uses that RFID process. They don't do it in a big press the way that DR Johnson does. They have that equipment that comes from Denmark that starts with a K. I can't remember the name of it exactly, but it's very interesting. It basically fries the glue, and it can only do a short segment at a time, but then that moves through. But anyway, there's a number of different ways of making CLT, but they basically zap the glue so it dries really quickly.
That's the technical term. I read it in the spec that SRG put out. Zap.
Zap? Was that what you put out?
Yeah. No, it's very true, Judith. And I think, for everyone, I think there's a lot of benefit in really kind of visiting with these fabric manufacturers and really understanding their individual processes. We've spent a lot of time in doing that, and I think it really kind of complements a deeper understanding. Get strategic with the solution. So.
I think the manufacturer is a Kolesko. Is that right, William? Is the Danish manufacturer of the equipment. And it does beams and columns as well as CLT panels. So I have been wondering about the efficiencies of that because, usually in the big presses, they do, big panel or sometimes stack them all at once. Here, but it takes, 45 minutes to an hour to press versus, 5 minutes for each segment that fits in the machine, but they can only do whatever it is, 6 feet at once or something, and they keep feeding it through. Anyway, more questions about the analysis of the most efficient way to both manufacture it and to install it. Colesso, thank you, Tom. I was close. Mm-hmm. Hey, Evan, do you want me to say a few words about the acoustic lab?
Sure, I think there'd be some interest there.
Yeah, it's Professor Kevin van den Wijmelenberg's project. Really, I'm helping with it as a representative of the Tallwood Design Institute. But we just completed the design development set for the design of the acoustic chamber itself, and we're about to put out an RFP, we hope, for the design and construction of the acoustic lab itself, which we plan to have completed by December 2021. And we'll be able to test a whole variety of mass timber assemblies. In the meantime, and I'm sure many of you know this, Kevin and his group have tested a number of assemblies in a facility in Illinois. And the results of those assemblies, which are both CLT and mass plywood, are available on the Tallwood website. If you look under research and testing and under acoustics, you can find them there. And of course, the NRC up in Canada has a bunch of other tested assemblies, but we know there's an infinite number of them that could potentially be tested. Kevin also has field testing equipment. So that's another possibility. If you're interested in something that's already been installed and you want to see how it's performing, the lab can also do that. Mm-hmm.
Thank you, Judith. Any more questions? William, I was wondering, so Swinerton has gotten into fabrication. How has that been for you guys? Has that affected how you procure materials? I mean, do the manufacturers actually really appreciate that they can sell you basically just like flat out, panels and then not have to think about it beyond that? Or how's that been going?
Well, I think it's a longer, there's probably a longer answer and a shorter answer. It's going great. would be the short piece, but I think part of what we've really tried to do in our approach is really look at how we can work with manufacturers to create flexibility in the market and remove bottlenecks. And I think that's really kind of the overarching piece. I think as we've completed over 10 projects now, and probably have about 6 in construction and more than 20 in pre-design and pre-construction, it's really been about looking at opportunities to advance mass timber's implementation into different market sectors, but also looking at how we can engage with the supply chain more actively to make it both cost competitive, but also yield all of the benefits that we're really seeking to do with mass timber. And I think the fabrication piece, and in some cases that's still with the same fabricators. In some cases it's with the we'll be able to supplement that with some of the areas that have been bottlenecks in the industry to date. So it's more of a partnership.
Sorry if I missed it, William, but did the Swinerton shop do all the fabrication of mass timber for this project?
No, Vaughan's doing it. Vaughan's doing the lion's share of the fabrication, and then we're working with Zippo on the glue lamp. So Vaughan's helping us even with the Ferris piece for now.
Oh, great.
This is Jared. From an owner standpoint, I can't say enough about how well this team has worked together and really pushed our goals. I kept waiting for the two of them to say uncle, and really they kept just moving forward. And so, yeah, I just want to say thank you.
Thanks, Jared.
Thanks, Jared.
Well, great. Any last questions?
Jared, can you talk about why using mass timber was actually a priority for this project?
So the bond for our project called out a meaningful or a demonstration use of mass timber for the building. And so as we went through and evaluated what that meant to this building, we were looking at certainly the value proposition that mass timber can bring. Obviously, it has aesthetic and meaningful feel to the building from a learning standpoint. And so as we looked at how we could implement that meaningful or demonstration use of mass timber in the building, I think we found that we could probably go beyond that low bar and do more than that. And so that's kind of how we got there.
Jared, could I just add to that there is a proposal from Oregon State University, University of Oregon, and Eastern Oregon University to the legislature for getting bonding for three university buildings, one at each campus, specifically by arguing that they would be using mass timber, which of course, the state was interested in for economic development terms. So that was the specific premise of the proposal. And as you said, in order to get the bonding money, that was a requirement. So OSU, the Cascades building uses an enormous amount of it. I haven't been following what's going on at the Eastern Oregon University campus, and the Knight campus used some CLT in the mezzanine areas of the at U of O. And William, I believe that Swinerton did the install of that CLT.
Yes, we did. It was a beautiful demonstration piece for a connecting element, and then some mass timber stairs that are part of that. And so, yeah, we had the good fortune to be involved in supplying and installing that.
Right, but it really was part of a state effort a state legislative effort to essentially get more mass timber product out there in demonstration buildings and public buildings to encourage more use of it in general in private and public developments, for the economic development and also for the sustainability aspects of it.
All right, any last questions? Somebody's dying to ask. Okay, well, thank you guys so much for your presentation, William and Lisa. It was really awesome.
Thank you.
Really beautiful building. So thank you for taking the time to share it with us.
Yeah, no, thank you very much for the opportunity. It's
Thank you.
Super project, once in a lifetime.
Can't wait to see it. Yeah, can't wait to see it.
Very nice presentation. I'm looking forward to the recording so I can review some of the more technical details again.
Judith, you know where to reach me, so by all means.
And Lisa.
Yes.
And Lisa as well.
Yeah, I'm looking forward to eventually seeing it in person.
Yeah, we're gonna set that up. Last week was not the week for that. We're gonna find a week here in the near term.
When are you slated to have the roof on?
So we're working to improve that date, but right now, since Jared's on the phone, I'll say that we'll put a roof on in November, but we'll improve that. So.
Cool. All right. Well, thank you, everybody. Look forward to seeing you next time. Again, that's going to be September 24th, and that's going to be with KPFF. We'll be talking about seismic systems. And the week after that is going to be innovative seismic research. So keep tuned. We'll be sending out a newsletter with all the details soon. So hope to see you there.
All right.
Thanks.
Thanks, Evan.
Thanks,
All right.
everyone.
Thanks, everyone.
All right. Bye.